This is my model, and I have finished it, and it's working very well. Now, in order to walk you guys through this process, I will start from scratch. And let's have a model 3. Let's model a new model, model 3, okay? And so this is okay. So this model 3 is an empty model. I want to build the model that I ask you guys to build. And first, if you have never used ABAQUS, you should go to the file, okay, and set work directory, and you can select work directory and to specify the directory that you want to open the files from, and you want to save the files to. So this is a set work directory. And for my case, I set this one on my desktop quiz 1, and you can select a one that is okay for you guys. Okay, so this is very, very important. And then you can just build a model. Build a model. Now let's get started. First step, and build the part. And for Kyle and Killian, and also Wei Bing Jiang, and these 3 guys know how to build the model using ABAQUS. For other students, Brian, Ashwish, and Vishnu, you guys have never used the ABAQUS, so I want you guys to watch the videos that I posted already first, and then watch this video. And otherwise, you guys will be feeling overwhelmed and will be frustrated. Okay, guys. So this is a learning curve, from the easier one and to the complex one. The Oscar, I think Oscar knows ABAQUS very well. Oscar is my graduate student. And now let's get started. Okay, first, and build these parts. Let's double click these parts here. So then this dialog appears. So in the classroom, when I teach this one this Monday, I taught you guys to build a 3D extrusion and make sure the thickness equals 1 millimeter, right? So now I give you another way. Another way is much better way and to do it. And we are going to use the 2D planar, and you can compare. If you are interested, you can compare. And one is use the 2D planar that I'm going to talk about today. Another one is use the 3D extrusion, and that I mentioned this Monday in Monday's class. So let's build this part. Okay, I just use this name, the default name, part 1, and the 2D planar, and this is shell. Okay, is approximate size, and look at our size. Our size is I think you guys already know, right? Because this Monday in the class I showed you on what dimensions I want you guys to build, and for this is the model. And for our case, I think 200 will be good enough. So I just select. So one thing I want to emphasize is that ABAQUS does not know the dimensions. It is your responsibility and to be very, very careful when you select dimensions. And for our case, and I want to emphasize this one. For our case, the force we use Newton, right? However, the dimensions and we use millimeter. As a result, and the stress will be megapascal. And also Young's modulus, and you should enter Young's modulus in megapascal. So this is very, very important. ABAQUS does not have its own dimensions. It is your responsibility to make sure the dimensions are consistent. For our case, the force we use Newton and 290 newtons, and the dimensions, we use millimeter. As a result, the stress will be megapascal, and the Young's modulus, you need to specify Young's modulus in megapascal as well. So this is very, very important. And for our case, this is millimeter. So it's very good. So millimeter, and so we want to build this model. Okay, I'm going to show you guys. And build this model. Let's draw this model. But here is a draw line, right? So this is a create lines, and I select one point here, and then this is horizontal one, and then this is another horizontal one, right? And another the horizontal one. So after I get here, I can either click this X or press escape is a button, and to just pause this procedure. And why? Because now I want to dimension all these these three light segments I just specified. And how to dimension? Use this one and dimension. Click it. So this is highlighted, and here, so you can specify. So here, this is 12.5. This is 12.5. I'm sorry, I need to delete the original one. 12.5. And then I need to specify this one as well. Click it. So this one is 25, right? This is 25 exactly, and what we want. Enter, and here is 25 also, and so this is exactly what we want. Now we specify this one. Why we want to do that? Because we want to dimension it first, and then we draw other light segments. You need to be very, very careful. This H means that these three light segments, and they are in horizontal direction. So this H means that they are in horizontal direction. This is a constraint for these three light segments. And then we draw this is this side. Use this one. Draw this side. And go here, vertical. See, you see the V, and V means this line is a vertical. And then, draw this one here. So this is H, horizontal. And then here, we have an enclosed shape, and this is a V. And then we can X this procedure. Now, we need to specify this dimension, and we use this dimension tool and go here. So this is the height is equal to 31.25. 31.25. Here we go. 31.25. And so because this guy, because of this rectangular shape, so this length of this light segment equals the sum of these three guys, right? So, and here is, this is the left edge. I need to tell you, this is the top portion. I told you guys, for this crack, for this specimen, and because of symmetry, and we can just model either the top portion or this lower bottom portion. For our case, and we draw this is lower top portion, okay? And then when you draw a hole, this is a pinhole that we are going to apply. This is the load on. Let's see the pinhole. How to draw the hole? I need to do the center. Okay, the center. We know that the center is let me take a look at the center. Just 1 second. This is the dimension. Is so the H1 and H1 equals 0.275 W. W is the width. W is let me try it now. Okay, so and so here is the H1. I go 2.5 multiplied by 50 equals. Let me show you guys. So okay, 0.275 multiplied by W with 50 equals 13.75. So this is the height, 13.75, and it is here. Okay, so I'm going to draw the point, create at least a point. Then you can see this is the coordinates are shown here. So here, right? So here you can see, and here is 12.5. So the center of the pinhole and should be on this vertical line. And where it is, and we know that the distance from the cracked surface and to the center of the pinhole equals 0.275 multiplied by W, which equals 50. That means it means the height is 13.75. Here we can see the coordinate of this point is y equals negative 25. So above negative 25 plus 13.75. So let's see how much should we go. $11.25. Let's go here. 11.25. Make sure. So this is this is a vertical line. So 42.5, right? 42.5. Here is 11.25. So negative 5. Go above. So 11.5. 11.25. Yeah, 0.25 here. This point. So this is actually the point, and which is the center hole, which is the center hole of center of this is a pinhole. So we can see, okay, we need to double check this guy's position. So the y coordinate 11.225, right? 11.25. The distance between this one 11.25 and to this is 25, and the distance is 11.25. Is 13.75. It's exactly the distance that we need to specify. So you make sure, so this point, and they are on the same, this is a horizontal vertical line. So it is x, for this point, x equals negative 42.5. For this one, negative 42.5. Okay, now, so this is center. We got this center, and then we just stop picking a point, and then we got the center, and then we need to specify a hole, right? Specify the hole, and how to draw the hole here. You can see several tools. So this is a circle, create a circle using the center and the perimeter, and so here is create a center and the 2 endpoints. So these are 3 points, and we use here, okay? center and the perimeter, and put this center, and then we draw a hole. Now here is a hole. Now we can specify the hole's radius. Now we want to X this one. So now specify, how to specify, and we still use the dimension, and then we highlight this is the hole, right? And then we know that this is R, okay? What is R? R should be, I calculate this one for you. R should be 6.25, and just enter here, 6.25. This is R radius, right? So I just enter it. Now here is a hole now, and so this is specified as well. Now I create my sketch. You can see that I create a sketch and just click this X, and then I just say done, right? We have done everything. So this is the edges and also the pinhole, and we have specified them. So this is specified the dimensions here, and also this the pinhole is specified, and then we say done. Now, and this specimen is this part has been created. Next one is material, and we need to specify the material parameters. And go here, double click it. So because this is linear elasticity, and we just need to specify mechanical elasticity, elastic, and we specify this as a topic. The Young's modulus, I told you guys, Young's modulus we use this must be specified in the megapascal, and we use 210,000. So this is megapascal, okay? 210 the gigapascal, and the Poisson's ratio, and we specify this as 0.3, and don't change anything here. After you get here and you press OK. Now this material, I just specify material 1, it's okay. Now you can see, and here this within these parentheses there is number 1. That means one material has been created. Next step is section, okay? And you need to create a section here. Look at here, the section, double click it, the section 1, and use the solid. Use homogeneous, continue, and the material. So this is material 1, okay? I need to tell you guys, because we are using this is the plane string. We'll click this one, right? And make sure the thickness is unit thickness 1, and then click OK. Some students might ask, where should I specify the plane strain or plane stress? That depends on the mesh, the elements I'm going to show you guys, right? And click OK. Now, after I specify the section, after I created the section, I need to go back to these parts and to specify the section to the parts, right? To connect the material and with the part you just created, and go here. So section assignment, double click it, and then so this one appears. Select the region to be assigned a section. I don't need to create a set, so just toggle it off. Select the region to be assigned a section. I want to assign this section for all this region, and then I just click highlight this one, and then done. And which section you want to specify to this part? And because we only have one section, I just select section 1, right? Thickness, assignment, and this is from section. Yes, okay. Now, so this guy becomes green. Now, become screen means that you have assigned section or sections on the part. So this is our section assignment for parts. Next one is that, and we create assemble. We create instance. Go here, assemble this instance, and double click it, and so there is a create instance from parts. And part one, we only have part one. So a dependent, I just select using this is a dependent one. Okay, so you can toggle this on and off, and you can select, you can choose either way. If you select this one later, if some problem, some error message, you can just come back and to select this one, and then press OK. Now I create an instance. After I create the instance, then I need to create. This is the step, right? I need to create a step, and how to specify create the step. Double click it. This is initial. We have initial step. If you do not do anything, there is initial step, and then we click a step. And this is step one. Just the static general. That will be okay. And for we just just in case in large deformation, we just click this on and press OK. Now we have those steps now. Okay, guys, questions so far? No question? Now I'm going to teach you guys and how to partition the part. And in order to partition, you need to be careful. For our case, because there is a crack, tape, right? Here is a crack tape. So in the neighborhood of the crack tape, and we need to use very, very, very fine mesh. So in areas that are far away from the crack tape, you may use coarse mesh, right? And you can still use the fine mesh if your computer has that capacity, computational capacity, and your lessons are okay. If you use research lessons, and you can use millions of elements, millions of nodes, it does not matter. Yeah, for our case, I want to use fine mesh here and coarse mesh here. Or how can I do that? I need to partition and this part into two parts. I'm going to partition? I'm going to cut it from here. This is the horizontal line. This is a horizontal line that crosses the center of the pinhole, and I'm going to cut it this one, right? Also, I'm going to partition because I told you guys, if you apply the concentrated force on the top of this load, and you will on top of this circle, and you will have stress concentration. So there will have severe deformation here. So your results will be poor. Because of this, I need to get some data points along this is the top, is the circle, and then I partition it, and then I can specify the loads on them. Also here, I need to specify I need to partition them, create data points first, and then partition. This is the bottom line. I'm going to show you, okay? And first, I'm going to have this is so here is one point, and here is one point. I'm going to, in addition to these 2 points, I'm going to create 9 uniformly distributed, 7 uniformly distributed the points. And let's do it, okay? So be very careful. So this is the technique. It's very, very. This is a technique you need to be very, very careful. Just 1 second. So you need to create a data point, and how to create data point and go here. The tool here, right? And go assemble and go assemble here. And go tool here. So there's a datum. And here's the datum, the type, I use the poise. And how to do the poise, right? I'm going to do one by one. And here, I want to, as I told you guys, I want to draw a horizontal line that passes this pinhole, right? So first, I want to specify a point here, specify a point here, specify a point here, and specify a point here, the horizontal line. So let's see the offset from the point. And then they will ask, okay? See, you can see that here the middle point always is specified. And offset from the point. I want offset from the point from this point. I want to select here. Okay? Then offset. Offset, so you can see, let me show you. So this is X direction, positive X direction. This is positive Y direction. So I wanted to have a point here because I know that the distance from here to here is what? I know that, right? How can I know that? Because I know the center, the distance between the center and to here. Let me show you guys what's that one. So that is the center. The distance between the pinpoint center and to this left edge equals 12.5, right? 12.5. The radius of this circle is 6.25. That means the distance from here, this point and to this point will be 6.25. So I will say where to go and in the negative X direction. So this is here, and I just say offset here. Okay. Negative 6.25. Negative. Then I just enter. Okay, you can see this one. So this is data point I just created. You can see that this one is a little square, is not a dot. Not dot means that, and you need to partition it. You have not partitioned it. It's just the geometrical the point. Questions? Okay, no question. I'm sorry, you cannot ask me a question. And then I need to specify a point here. Right? How can I do that? I use the offset from point, and this time I use select the point from which to offset. I select this, the bottom right. And where? How to offset? Offset from here, X positive X direction. I know that, right? So I know the center or the distance between the center of pinhole to the bottom edge equals let me see, 13.75. I just say for the Y value 13.75. I just enter. See, you can see, and this point is created. Okay? Questions? Now, after I create it, I can partition it. I want to show you how I can partition. So how to partition? Let me partition this one first, okay? Let me partition. Here is a partition. To create a partition. So this one is a module assembly. So use this one, create partition. So how to this create edge? We use edge. This is 2D. So what's that? So use this is we use this select data point and select the data point. Okay. From here, Okay, what I'm sorry. So from here, select point on edge and select this one. Now create partition. Now see this part. This is created, right? This I told you guys data point after data point you need to create partition, and then next one set point select edge. I select this edge, and then select point. I select this point. Then create partition. Now this one is a partition. I create a partition. Right? So face. Just 1 second. Create a partition, edge, and select midpoint. Yes, it is partition. You can see it's a partition. So here you can see partition, right? You can see partition. These 2 points are partition. This edge and this edge is partition. So we parse the face now. We use shortest parse between two points, and we select this one, and we select this one. Shortest one is a straight line, right? Now partition. See, you can see partition, right? And then from here to here, select the start point, and then select this end point, and then create a partition. Now, this is partition, this is partition. Now we have 2 parts. This is the top part, so this is the lower part, right? And then now we need to select the 7 points. So we have this point and this point. Let me X this one. We have this point and this point. So then we want to have 7 points here. So how can I do that? As I told you guys, we need to create data point first. So create data point tools and data point. Now this time, and we use this is enter parameter. We enter parameter. So see, select the edge on which to create a data point. This is the top surface. It's a top circle. See, you can see this arrow. Okay, this arrow means that it's a start from here to here, and because it depends on how many points we have. We want to have 7 points. So 7 points in the middle. That means we have 8 the light segments, right? 8 the small light segments from here to here, right? And then, so the edge parameter, so t equals 1 is length. From here to here is 1. So because we have totally 8, the uniform is equal is a small light segment, and here we should use 1 divided by 8. and which equals 1 divided by 8, 1 divided by 8 equals 1 divided by 8 equals 0.125. Okay, so and we should have here 0.125. See, and this point appears. Then select edge on which to create a data point here, and now edge parameter, and so this is second one, and this one multiplied by 2.25. Okay, and then select edge on which to create a data file here, still here. Now this time we enter another 0.125, 0.375. And then select the edge on which to create a data point. And then here, and will be 0.5, right? Because each small segment equals 0.125. See, just in the on top, very top. And then select the edge on which and to create the data point. And so this time 0.5 plus 0.125, 0.625. 625. And then 0.625, 0.625 plus 0.125 equals 0.75. And 0.75. 0.75. Then the same thing, and 0.75 plus 1.25 equals 875. Let's put 8 here, right? Okay, after here, and another one you go to here. This point we already know this point, so we don't need. So we have 1, 2, 3, 4, 5, 6, 7. We have 7 new data points, along with this one and this one, 9 points. We are going to apply this nodes this way. Now I have these points, and then I'm going to partition it. Okay, and use the same thing. And this is the create data point, and then I partition. So partition, and we use edge, right? We are partitioning on edge. So we use this middle point or data point. Select the edge to partition. So this edge I'm going to partition. And select a point on edge. I want to select this one. Partition it? Yes. Okay, so you can see it changed. Select the edge to partition here, and select the point on the edge here. Partition. So this one is partition. Okay, you can see the light segment. Here, this here is still a bigger segment, right? So select the edge to partition. Select this one. Select the point. Select this with partition. And select the edge to partition. And select the point on the edge. Select this point with partition. And select the edge to partition. Partition this one. And select the point on the edge. Select this one. Then partition. And select the edge to partition. Is repetitive is work. Select the point and select edge to partition. select point. Partition. Now, and we have partition now, right? The partition, you can see the small light segments. No, I don't select. Now I have finished partition. Now I want to show you. See, this is light segment, light segment, light segment, light segment. Also, the midpoint always automatically generated. So I have created them. Right? Now I'm going to apply the load now. I will not apply the load. I'm not apply the load now, but I want to partition further. Let me partition now. This time I partition. Now this time I'm going to partition just near the crack tape. Right? For the near the crack tape, and left to the left to the crack tape about 6.25 length, and to the right to this crack tape also 6.25. So I want to because I want to have very this is fine mesh near the crack tape, so I need to partition. I need to partition further. I need to partition this one first, okay? And then I need to get this data point. Data point, I want to use the offset. Now I know that, okay? So this is a crack tape. This is a crack tape. Why I know that? Because I know that here equals here is a crack tape. So this here is a crack tape. Now, this is a crack tape. I want to select point from which to do offset. I select here. As I told you, I want to offset from this point back to the left for 6.25 in X direction. 6.25. So make sure this is negative, right? Because negative 6.25000. Now I have here, and then I select point from which to offset. I will still use this crack tape, and now this time it's in the positive X direction, 6.25. Enter. Now you can see I have two points, right? Then in addition to these 2 points, I'm going to depart the partition further. And I'm here, I know that from the crack tape to the left and to the right, I need to have, we are very interested in the length of 1.25, right? 1.25, and in this one, I told you guys, you need to plot distribution ahead of a crack tape for epsilon is less than x less than 0.05a. 0.05a, a is 25. 0.05a, a is 25. That means multiplied by this one is equals 1.25. We are interested in this, so I need to select the point from here, still the crack tape. Now this time from the back minus 1.25. 1.25, right? Okay. Here. Then select point this is the corrective. This time in the positive x direction, 1.25. 1.25. Now see, I have these two new points. Then I'm done. I'm done now. So I create, here is the corrective. Here is the corrective. Now I have this one, this one, this one, this one. Now I need to partition them. You can see this line segment is still the whole line segment. I have not partitioned it. Now I need to partition. How to partition? And here, I use this one. See, just like scissor cut, right? So this is very, very intuitive. Create a partition, and using the data point, right? And select edge partition. I want to partition this one. Select point on the edge, and so I will select this one. Partition, right? Okay, I partition. Now select the edge partition. I want to further partition. So this goes to the corrective, further partition. And then select point on edge, select this one. Okay. And then I select edge to partition. I partition this one. See, yes, it's partitioned. So this is corrective. I want to select edge to partition. I partition this one, right? And select a point to partition. I want to here. Partition. I partition. Okay, and here is another one. See? Select the edge. And select the point. I'll create partition. Okay, I create a partition. Here you can see this is a small segment. So here in the middle is the corrective. Now see this left segment, this left segment, and this left segment, this left segment, this left segment. So this one, and at the very beginning we draw them. We intentionally give this a point here. So this is, we did not partition here, but we partition in other place. Now we have created data points, and we have partitioned the line segments, edge, the surface using the segments, using this the data points, and then we can apply boundary conditions. Right? See, let's apply boundary conditions. This is a loads concentrated force and continue. So we select points for the load, and we select this one, 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 this one. Okay, done. And what do we want to? So each load, we have nine points, right? 9 points, 290 and 290 divided by 9 equals what? Let's calculate. 290 newtons divided by 9 points equals 32 and 0.2222. And you can just using several. You remember this is the going up, and 32.22222. That will be good enough. Yeah, okay. See, I just apply these notes. Any questions? No question? Okay. No question. I'm going to apply the boundary conditions. What is the boundary conditions? I told you guys. I told you, so this is our crack tape, right? And this crack tape needs to be fixed in both X direction and Y direction. And for other points on the ligament, and they need to be fixed and in the Y direction, but they should be able to move in the X direction. So let's apply boundary conditions. Boundary condition 1, the displacement, we use displacement, rotation, and continue, and select region for the boundary condition, right? So here is a crack tape, I told you guys. The crack tape, and I can select this one, or you can just press this one, use the shift. Oh geez. And also use this one. I can select these 3, 1, 2, 3 segments. Done, okay? And what is the boundary condition? I told you for the ligament points, and they cannot move in the Y direction. So Y equals 0. For other two, and we did not specify, means that and they are free to move. So press OK. And you can see here is specified, right? And then I told you guys, in addition to that, and you can specify, you can also fix the crack tape in the X direction as well. So double click this one, displacement, rotation, boundary condition 2, continue. Now select, this is the crack tape, then done. And what does U1 equals 0, right? You cannot move in U1 direction, so equals 0. So you can see here's a crack tape. Crack tape is fixed in both X direction and Y direction. Questions? Now, don't forget to save your file. Always. Questions? Comments? Now, so after you apply the boundary conditions and loads, I would suggest you guys, and for the boundary condition, right-click your mouse, right-click, and here go to manager. The manager, the boundary conditions, and they should be applied from the initial stage. Okay, move to left. Is move to left. So also for the load, you need to make sure the load is applied on the correct step. Right-click your mouse, manager. Yeah, it's good. It's step 1. Okay. If you have multiple steps, you need to be very, very careful. Now, don't forget to save. Now, the last step, and it's a very, very important step, is meshing. And I told you guys, for our problem, this part is far away from the crack tape. We can use the relatively coarse mesh. Here, especially around the neighborhood of the crack tape, and we need to use very, very fine mesh. Right? I'm going to tell you guys what mesh I use, and you need to be very careful. First, and go to the mesh, save it, and go to the mesh module here, okay? And how to mesh it? And you need to see the edge. Look at this one, see the edge. And you select the edge to be seeded, a local seed. For here, I specify this one a number, and what I use is 20, and you can just follow mine if you don't mind. The 20, even the 20. Select the region, select this one, right? The top. The top I use 40 because it's long. Okay, you can see it's specified, and from here, one. I also use 20. Okay, you can see here, and from this, I specify 30. Here you can see this is a seed. Here I specify 10 because it is relatively short. Okay, and then I need to specify these light segments, and because this round one, not straight line, and you need to use relatively fine mesh. And for my case, I use 12 for each of these segments. For this one, 12. For this one, 12. For this one, the ABAQUS is very good by default value, 12 that you entered in the previous step. This one, 12. 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 Right? Questions? Okay, if no question, let's yeah, we can mesh it. Let's see what will happen. Mesh the top one. So we can here use this one, assign mesh control. This one, fine. And we use a free, okay? We can use this one. That's okay, that's totally fine. And then assign the element type for this. And I told you guys here, and we can select, this is a plain string, right? Here. And don't change this one, stat linear. And we press this. Now we have finished this one now, and we done it. Now we can mesh it, right? Use mesh. So here, go here, mesh here, mesh the region. Here, we done. See, it's meshed. Okay. Oh, it's for the for this is for this part. For this lower part, we can use that one. Okay, we can use and also need to specify here. Let me look at my. Here, so I still the seed. For here, I can use 69. Okay, one. You don't need. You can just push 50. I'm sorry. Select this one, and 50. see this one, done, and 50. So this one, done. We use 94. We can use 100. And here is because it's coming closer to the tape, and we use 200. And here is much closer, and we use 100. Now here, very close to the crack tape, we use 100. Here, $200. Here, we use 100. Now here, we use 50. Done, I'm sorry. Done. Here, because we do not know, we can use we can see for 12 for each of these segments, 96. We can use 50 because we do not have apply load here. That could be good enough. Let's use 60. Okay, we're done. Right, and then we need to do assign mesh control for this part. Done. And we use the trigonometry, this trig and free. And then this assign element type also for this region. Done. So standard linear trig and plane stress and plane stress, right? Be careful, plane stress. And so this is okay. And then we just mesh it. You can see this very fine mesh, right? Okay, done. Now we have done everything. Okay, we have done everything now, and the next step will be I have this job, create a job. So this model 3, job 3 for model 3. This job I will say crack A20 demo. Continue. And click OK. Now this job is created. Now I can run it, okay? I can run it, right click it, submit. And this guy is running. See, has been submitted for analysis and completed successfully. Let's see, it's running now. You can right click it and see the monitor, and you will see and how far it is going. So we're done. Right? So this is 1 because we only have 1 step. And you see they completed successfully. Now we can visualize the results. Right click it, results. Now I have deformation. This is my deformation. See, it has deformation. This vomicis stress distribution, and we have finished. Now, what we want to do now? Okay, I'm going to show you on how to get the response, this reaction force on this segment. I'm going to show you guys. Okay, so here, and you can active animation. Have animation is very funny. Here you can just lower the frequency, and you can see other. So this is vomicis stress. You can go to the results here, and go to the field output, and to select what kind of variable you want to visualize. So for example, for this stress, I want to visualize S11. S11 is X sigma XX, and I want to visualize this is sigma 22. Sigma 22. We are concerned about sigma 22. I want to visualize the displacement U2. Right? I want to visualize the reaction force RF2. So don't panic. Here is very hard. It's very dark because we have many mesh there. And you will see something here. Now what I want to show you is and how to get this is a reaction force. How to get the reaction force, guys? Right? How to get the reaction force? Go to the parse. I'll create a parse. I'll create the edge list and continue. Now, and before. Now we want to select the ligament. And I want to enlarge it. I want to pan it. I want to enlarge it. I want to enlarge it. Maybe deform. I'll go here. What? So here is the very large step. So you can see I want to go from here. This is my correct tape. So I want to use this is a R force. Make sure I'm outputting reaction force RF2 here. And I'm creating a part. I'm sorry. Just 1 second. I'm creating a parse 1 edge list. And pan a little bit. Here. Continue. And before. And select this feature edge. Right? Select the feature edge. See, all these nodes on the bottom edge will be selected. I will pan it. I want to take a look. See, all these nodes are being selected. Yeah, this is a coarse mesh. Okay, I'm okay now, right? You don't need to go very to the rightmost. And I click X, then done. Now this is the parse 1 has been established. Now this is parse 1. And then I go to XY data, and XY data will be built based on the parse. Continue. And build on what? And the parse 1, see, specify parse 1. And field output, which one? RF2, the reaction force in the Y direction. Okay. And then I can either plot it, see? So this is the force, okay? Very beautiful. You can show this force for me. And also I can save it in the Excel file. So XY data -1, click OK. So here I have XY -1 now here, and then cancel. And then how can I output the data file onto the Excel file? And go here, plugins, right? The tools, Excel utility, and which one you want to do. I want to work on XY data 1. Okay. See, the Excel file is open. Now this is very close to what I just showed here. Okay, guys. Now some students might ask, Dr. Mark, can you show me that the sum of the reaction equals the force we just applied? Yes, I can. So here equal sum for this column. Come on. Okay. Okay, see, 289.996. It's very close, right? Very close to 290. You understand? Yeah, you are pulling that way, so the reaction force here will go in the opposite direction. It's understandable. So this is a very good one. Questions, comments, remarks. So you are going to use this technique and to get the reaction force, and when you apply it, the displacement, and that's for the decontrol. This is the energy method. Questions so far? Oh, no, I'm sorry. I usually ask my students questions. Now, then I'm going to show you on how to draw the curve, right, from the for the stress method. From the stress method, stress approach, and we need to draw the sigma yy from the epsilon to the 0.058. 0.058 equals 1.25. And let me draw that one for you. Then I'm show you how to post process it. So I want you guys, maybe if you are interested, you can put this one in your report, right? And then let's see. Let's go here, and let's use this one to go back auto filter view, right? Now this time I want to create a parse that is only from the correct tape and to the position that is 0.05A away from the correct tape, and 0.05A equals 1.25 millimeter. So I need to create another parse. I will click it, the parse 2, okay? And this time I will not use edge list. I want to use this node list. Just 1 second. I need to need to pen it. So this is how you can see, right? Very fine. Mesh is very, very fine. So it should be here. Right? Let's see which point is the last point. Let's see the distance. Tool here, query, distance. So this is all corrected. From here, to here, 1.25. It's around here, I think. Okay, let's see. Let's double check. Distance. From the second point, let's pen it. I think it should be here. It's around, it's okay. It's totally okay. 1.25. Let's see here. This point. So we need to select the points. We need to select the points, okay? From here to the 1.25. So we need to plot this one, node list, and before. No, I will not use this. Cancel. Add list this time, and before. Now we use by shortest distance. Right? Select edge to be selected. Select end node. Done. See, this one selected. Okay. Now I need to create XY data parse again. Now I select parse 2. And so what do I want to output? I want to output SY, the sigma YY. Okay. I can plot it, right? This is, I can plot it. I can save it as X2. Okay. Now I want to output it into this Excel file. Plug in tool, Excel utilities. Which one? XY data 2. Okay. So you can see this. This is my file. Now, I want to draw the based on what I my requirement, you need to sigma yy multiplied by square root 2 pi x. Let's see. Okay. So this is r distance. So in front of the corrective, and this is the corresponding sigma yy. And here we use this one, and this is sigma yy. This guy. Multiplied by SQRT 2 multiplied by pi pi multiplied by x. Okay, just 1 second. This. Okay, so pi, you need to write this way, and then I just pull it down. Just pull it down. 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 Okay. Now I want to draw these 3 ways. Insert. Okay, I don't want this one. I just want this. As I told you guys, as I told you guys, you need to throw away this. And let's see what will happen. Let's throw away. So evolution several few elements. 1.25 multiplied divided by 100. You can just delete that one, right? And then trend and a straight line linear, and also display equation. So here. Guys, so this will come here, okay, 1x equals 0. So you can see 394.48. So this 394.48, if you get this value, and your model is exactly correct. And so you the percent error, relative error will be very, very small. So this is how I do it. Okay, guys, and So this is a very long video, but it's very useful. It is. I want you guys to look at this video by yourself and make sure you understand all these steps, especially the students who have never ever used ABAQUS. Right? If you have used ABAQUS, for example, Cal, Gideon, and Vibin, you still need some time to digest what I just taught. So this value, this is my KI. This is my KI. So this value is very, very accurate already. I want in the lab report, I want to see your error message when compared with the analytical solution. Questions, comments, remarks. I'm sorry, I mean, I ask you questions again. So you cannot, this is a one-way video now. So I hope you guys enjoy this video, and